Looking at chapter 13, day 3, the fundamental theorem of algebra, and you can see there, the fundamental theorem of algebra, where every polynomial equation has at least one root within the complex number system. Now, yesterday we looked at real roots, and if you remember looking at real roots, those appeared as x-intercepts on our particular graphs, and that's where we were able to find them and do synthetic division or whatever is necessary to find the remaining roots. Today we're going to look at, well, what happens if we don't see all the x-intercepts? Maybe we're going to see, and those will be imaginary roots. So we're going to look at that today. Hopefully remember a little bit of algebra from that, and we're going to kind of expand on that a little bit today here. So as you see, you're going to have either real roots, we can know those are x-intercepts, or imaginary roots, which you cannot see on the graph, but they are there, and they do need to be taken account for. So linear factors theorem, which just basically says if you have a polynomial where a's, those are the coefficients, and x's, those are the variables. If you have a polynomial written in that form from the greatest degree down, we can do is we can write that particular function, that polynomial, as a factored form, where a of n is just whatever the lead coefficient was factored out, and then each of these groups is a factored form from there. And as you see, the r's, well, those are the particular roots that we're going to find for the polynomials: real, imaginary, or we'll talk about what happens if you get repeated roots. Okay, so that's what we're doing in the beginning here, is we're looking to take a polynomial and write it in factored form as a product of linear factors. All right, the second part that's here, we'll get to this on the back side of the paper, so just hold on to that for a minute. We'll come back to that, and we'll take a look at how you can take a quadratic or cubic and find the roots by looking at the particular coefficients. We'll get back to that in a few minutes. All right, so the first thing they're asking us to do is express the following in the form, right? That basically just saying this is the factored form. Okay, and again, the r's represent the different roots that you find for each particular polynomial. So if we look at number 1, so as we said, we need to factor this. And if you remember, when you have 4 terms, the one thing you should try and do is see if you can factor by grouping. So what I'm going to do here is I'm going to put quantities around this. Now, the tricky thing is this needs to be a plus sign in the middle here. So what I'm going to do is, if you remember, I'm going to write that as plus a negative 2x. So that way I have a plus sign in between the two quantities when I want to get to my factoring. So it's still negative 2x. I'm just going to put it instead as a plus a negative 2x. When I look at the first group, I say, well, what can I factor out of that? Well, I can take an x squared out of that. If I take out an x squared, I'm left with an x plus 1. Now remember, the reason why we changed that minus sign to a plus a negative is because if you see a negative right here in the beginning of a group, you must factor out the negative, and in this case, along with the 2. So when I factor out the negative 2, I get x plus 1. And hopefully you recognize, oh, look, they both have x plus 1 in the groups. That's the only way to do factor by grouping. You must get x plus 1 as those two groups. So I'm going to put that together in the front. Whatever I factored out goes together in the second group. Now, typically we would say, okay, we're done. You can't go any further. But if you look at the given up here, all of these are x to the first, which means that I need to factor that x squared a little bit further. So I'm going to go through and say, well, how could you factor x squared minus 2? And you might be looking at this saying, well, there is no way to do it. We haven't done that really in algebra class. You're right. Typically, we only do difference of perfect squares if that last number is a perfect square. It kind of is, because if you factor that, well, you can factor that. Well, we say x squared is x and x. 2, well, to get 2 is you could do the square root of 2 times the square root of 2. And one of them is a plus, and one of them is a minus. And that's a way that we haven't done often with a square root inside there, but that's how you would have to look at factoring, because they want you to get the particular roots that in each particular parentheses and have it x to the first. Now, one last thing I need to look at is it says that it needs to be a minus sign. So all I'm going to do is write this instead of x plus 1, really the root that comes from that would be a negative 1. So I'm going to write it as x minus the quantity of negative 1. Same thing with that plus square root of 2. I'm going to write it as x minus parentheses negative square root of 2. And that one, last one's fine because I already have a minus sign. And I'm going to leave it like this. And this is how you would write that polynomial as factored in the factored form where x minus a root, and a root, and you'd say those are your three roots if it was asking for that, right? -1, negative square root of 2, and positive square root of 2. Okay? So all you're doing is taking the polynomials and you're writing it in that form where you're writing into factored form. Same thing here. If you look at x squared plus 10, you may be saying, well, it's not difference of squares, so I can't really factor that. Well, actually, what you can do is, if you remember how imaginaries work, if I were to, because we're finding the roots, if I set this equal to 0 and say, well, how would you solve that? Well, probably what you would do is you would subtract 10, or I hope you would do that, subtract 10, and then take the square root. And this is where we talked about today. Yesterday we did real numbers. Today we're doing real and imaginary. If you look at the square root of -10, well, that's just going to be plus or minus. Remember, we have two of them there. I square root of 10. And you can't simplify the square root of 10, so you leave it like that. So what this means is this I square root of 10, these are the roots of that particular polynomial. So all I'm going to do is I'm going to write it in the form it said in the beginning, the factored form. I'm going to put x minus I radical 10. And then again, the other root is a positive one, so I'm going to do x minus parenthesis negative I squared of 10. And that is how you'd write x squared plus 10 into its factored form, where each parenthesis is the roots. Okay, so we haven't done much with i's, but here we're going to look at it a little bit today. So hopefully you remember dealing with that and solving an equation like that. Okay, so there you go. We got two so far done. Let's take a look at the third one. All we're trying to do is just factor this. So I got x to the fifth, x to the third, and x by looking at my x's there. So if you hopefully always do is you take out the LCD whenever you're factoring. You notice that x to the first is my lowest common, not LCD, it was least common multiple. There we go. Greatest common factor. Oops, my fault. Greatest common factor. That's what I'm looking for. GCF. So I'm going to get x. I'm going to take that part out first. Too many acronyms. All right, so I'm going to have x to the fourth minus 7x squared minus 18. So now I want to factor a little bit further. Now, depending upon your level of comfort with factoring, some of you might want to do some substitution. I have seen this in algebra class. Well, they'll let a be x squared, and then replace all of that and instead do x and try and do a squared minus 7a minus 18. Go further, then plug it back in. If that's your comfort level, then go ahead and do that. Some of you can go through and just look at this and say, well, I know that x to the fourth is x squared times x squared. What multiplies the negative 18 as the negative 7? Well, that's just negative 9 and positive 2. And so some of you can just go there. You would get the same thing if you went this route with it. This might take you a little less time, so I went that route instead. But do it the way your goal is to do it correctly. So do the way that you're comfortable with to make sure that you're doing it correctly. All right, and again, I have to make it x to the first in each quantity, so I need to factor that x squared minus 9. I'm going to make it x minus 3, x plus 3. Now, if you look at that x squared plus 2, this is similar that we just talked about doing it up here. Oops. Doing this up here in number 2. If I take the x squared plus 10 set equals 0, you see how I got plus or minus I root 10. Same thing if I were to take this right here, and if I were to go through and take x squared plus 2 set equal to 0, what I would find is I would get x equals plus or minus I root 2. If you don't believe me, go ahead and go through the process of step-by-step solving it. And so what I can do then is I can go and I can put this as my groups as x minus I root 2, close to room here, x plus I root 2. Okay, and so there we go. And so that's what I end up solving or getting for my different roots. But again, it has to be minus sign in each parentheses. So I'm going to take one last step. I'm going to say x minus 3 is all set. X plus 3, if you remember, that comes from the root being negative 3. So I'm write as x minus negative 3. This one is all set, x minus I root 2. And this one comes from the root being, as we just saw right there, comes from being x minus, the root is negative I root 2. And so all 5 of those are your particular factors, because if you remember talking about this in algebra class, we talked about earlier, if it's x to the fifth, that means you're going to have 5 roots, and there you can see it right there. Same thing with up here was x cubed for number 1, and that's where we had 3 groups, and then x squared, and that's where we had 2 groups. Okay, that's just a quick way to check that you found all your particular factors. All right, so going from there, that's just how you write out the polynomial into factored form. You're just finding your roots, real or imaginary, and then you're writing them in the parenthesis groups. Make sure you have x minus in each particular group, and then the root, if necessary, put with parentheses if it was a minus a negative, so you can show that is the root of that original polynomial. Okay, let's take a look at the back side of the paper. Now we're going to switch up on you a little bit here. Now your job, instead of writing in factored form, is to write the polynomial out. So one thing I don't like about this is I would prefer that you wrote it as equals 0, or to write it as f of x equals, because if you those are the roots, that means it should come from an equation. So you want to fix your notes on there, because that's what I would expect on your test and quiz. I'm sure your teacher's going to do the same thing. So if I take a look, what they're telling me here is that the root is 1. So f of x equals, our job is to write the polynomial equation. So if my root is 1, well, we know that that comes from the quantity of x minus 1 when you're solving. If you set that equal to 0 and you solve that, you would get x equals 1, right? That's what that's telling us. Our root is 1. Well, since you have a multiplicity of 2 on here, what we know then is that just means that this quantity is going to be squared. That's all that's telling us. Since the multiplicity is 2, we know that our quantity is going to be squared in there. Okay? Now, if I look over here, if I have negative 3 as another root, that comes from x. And I could put minus negative 3, or you can just put x plus 3. Now, the nice thing is I have a 1, so that's just going to be to the first power, okay, that we have there. All right, don't have to write the first power, but you can, if you'd like to, make you feel more comfortable with that. Now, if you look at the beginning, though, it says that we need to write it out. So even though this would be a great answer as a function written into factored form, it's not the answer that we're being asked to do. We're being asked to write it in this form written out, okay, as all your polynomial terms. What does that mean? Well, this means that we need to do some multiplication, or that your teachers may have taught you FOIL, however you want to do that here. What I'm going to do is I'm going to start with this x minus 1 squared. Remember, that just means x minus 1, x minus 1. So if you need to write that off to the side, multiply it out, do that. Otherwise, some of you I know are good enough that you can say, okay, I'm going to have x squared minus 2x plus 1, because you've practiced that enough. If not, then multiply that out. Okay, we haven't used the x plus 3 yet, so we're going to bring it down because we're going to use it next. All right, so far we have this. Now again, I need to write out all my terms, so I'm going to do some more multiplication. I'm going to say, okay, if I were to take x and multiply that in here, I would have x to the third minus 2x squared plus 1x. If I were to go through and I'll use a different color here. If I take the 3 and multiply in here, I'm going to have plus 3x squared minus 6x plus 3. But obviously, the way that it looks up here, I need to combine like terms. So go back to our purple and say, all right, if I combine like terms, well, I have x to the third. If I look here, I have a minus 2x squared, a plus 3x squared, gives me a positive x squared. I have a plus 1x minus 6x, gives me a negative 5x. And then I have a plus 3. And that is the polynomial that I was looking for. Okay, so what that means is that's the polynomial that if I were to factor it or solve it or do like we did yesterday and graph it on the graphing calculator and look for the roots, I would find that x equals 1 occurs twice and x equals 3, negative 3 occurs 1 time on that particular graph if you go back to yesterday's concepts. Okay, and there you go. So there's number 4. There's our polynomial in that particular form. And again, I like putting f of x equals or equals 0 because it's probably on the test or quiz, like a good feeling, hint, hint, it's probably going to say write the equation. So make sure you write f of x or equals 0, one of those. I always hate when students lose the silly point because they forget to add details. So be careful. All right, number 5, looking at that root. All right, so the root is 2, so I know that comes from x minus 2, and it happens one time, so you can put the first power if you want, not required. I have negative 2, so I'm going to write that as x plus 2. If you want to write minus and negative, that's fine, but eventually you got to put x plus 2. Now, the 2i, I'm going to write it just like I'm writing my other ones. That comes from the quantity of x minus 2i. The negative 2i, well, that comes from x plus 2i. Okay, so all I did is I wrote all those roots and I wrote it into their factors so that I can write this polynomial out, take the next step and do some multiplication. So f of x equals, well, I'm going to take this first group and I'm just going to multiply it out. The nice thing is you have difference of squares here. So you're just going to have the quantity of x squared minus 4. Now the next one, if I multiply this out, I'm going to have x squared. Now, here's the tricky thing. You may or may not remember. If you multiply negative 2i times positive 2i, well, what's going to happen is you are going to have negative 4i squared, right? So you multiply that part out, you got negative 4i squared. Now, hopefully you remember that I squared just means negative 1. So I'm multiplying this out. I'm multiplying out negative 2i times positive 2i. I get negative 4i squared, which just means negative 4 times negative 1. So all that means is I'm going to put plus 4 into that group. That's what I would get if I FOILed it out and cleaned it up. I would get x squared plus 4. Or if I had x squared plus 4 and I solved it, worked backwards, I would get 2i and negative 2i as my particular roots from that quantity. Okay, so I got to finish this because it's not multiplied all the way out yet. So if I do some multiplication, again, I got difference going on here, difference of squares. So I'm going to get x to the 4th. The insides cancel, and I'm going to get a minus a 16. And that is my particular polynomial for this. Okay? All right. Let's take a look up here at number 6. Now, here's the tricky thing when you look at number 6 is because it wants a polynomial in that form. All right. So what I have to look at is that you should realize that, or hopefully remember, that all your imaginaries come in pairs. So what I'm going to do for this is I'm going to go through and I'm going to realize that if R1 is negative I, well, I have another root that would be positive I, because all the imaginaries always come in pairs. Same thing over here is I'm going to put my 4th root is that in order to get this as integer coefficients, I'm going to have to realize that, well, if it's negative square root of 3, that another root would be positive square root of 3. Okay, so when I look at this, is I need to, if I want to find integer coefficients, I need to say that, well, I can't just have a negative I as a root. I also have to have its partner positive I. Same thing with negative square root of 3. I also need positive square root of 3. So this is what I'm going to use if it asks me for integer coefficients. So I have a feeling this is what this problem was trying to ask. If it wasn't trying to ask that, well, then this is really simply, right, this would just be f of x equals x plus I and x plus square root of 3. And then you could FOIL that out and get your answer. But I got a feeling they left it off, but they wanted to say, write this as integer coefficients. And when you say integer coefficients, that's why you realize that these have to come in pairs. Okay, so you have to have negative I and positive I, and then you have to have negative square root of 3 and positive square root of 3. So if I write this out, I'm going to say f of x. Again, this is if it says integer coefficients. If it doesn't, you can do it like this and then multiply it out, but I got a feeling they're missing the directions as integer coefficients. So let's do it this way for number 6 here. So f of x equals, well, I'm going to set it up. I'm going to have r minus I, r plus I. I'm going to take my square roots. It's the only way to get integer coefficients if I have the negative radical and the positive radical. So I'm going to say x minus root 3 and x plus root 3. You can have those in different orders, but you just have to at least have to have a group that has x, a minus I and a positive I, a negative square root of 3 and a positive square root of 3. So what I'm going to do is you've got to multiply it out. So I'm going to go through and just say, okay, well, if I multiply that out, I'm going to have x squared. The insides will cancel. Now, negative I times positive I, well, if I do that, I'm going to have negative I squared. Well, that will come out to just be positive 1. If you're not sure, write it off to the side and then simplify it out, okay? Same thing over here. I'm going to have x squared minus, well, square root of 3 times square root of 3 is just 3, right? Square root of 9, which comes to 3. And it's a minus sign because I have negative times a plus. And then remember, this was plus because I had I squared, and the I squared came out to be a negative 1 times the negative makes a positive 1. If you're not sure, multiply it out off to the side and then double check your answer. Okay, so now I'm going to go through and say f of x equals, if I multiply this out, I have x to the 4th minus 3x squared plus 1x squared gives me negative 2x squared minus 3. And this will be the polynomial that if you asked for integer coefficients, you would have those 4 roots. And you can see it's x to the 4th. Okay, I had to go over that and I went sloppy. There we go. All right. Okay, so there's our polynomials going through and multiplying out and then simplifying as much as possible to get it in that particular polynomial form with integer coefficients. Now, if you look at number 7, you can do it a couple of ways. One way you can do this is if you take f of x equals x minus 1 plus square root of 5, and then you take x minus 1 minus square root of 5. The tricky thing is here, now you got to do all the multiplication. So you're going to end up getting 9 terms here, right? 3 times 3, so you got 9 terms. To me, that's not worth all the time in doing that. If you remember, I said in the beginning of this, I'm going to go back to the front page here, okay? We talked about this over here. This relationship between roots and coefficients, this is what I'm going to look at, okay? What it says, if you have a 1 in front of an x squared, so if you have a quadratic, well, if you add the 2 roots, that will always be the opposite of whatever the coefficient is on that x term, so opposite of b. If you multiply your roots, that will always be exactly as the constant is. So that's just a shortcut way that you can use. And then there's written out for you if you ever have a cubic. So if you want to go back to the previous problem and double check that it worked, you can see now it's a little bit trickier again. You add the 3 roots, you get opposite of b, right? That's the b. If you multiply the 3 roots, that's the opposite of the last term. And then if you go here and you do partners, like you multiply the first 2, multiply the second 2, multiply the last 2, well, that comes out to just be c. Okay, and that you have right there. So that one we don't use as often. If you want to try it, go ahead and try that with some of the previous ones. But we are going to use that one above with the quadratic one. So what I'm going to do is I'm going to go to this number 7. And again, you could do this and you can multiply this out and negative 1 and square root of 5. It's getting all messy, right? I don't like it. Okay, so what I'm going to do instead is I'm going to go through and I'm just going to use what it said. It said that if I add the 2 roots together, I will get the opposite of b. So, oops, got a little, there we go. So if I were to add these 2 roots together, well, if I were to take 1 plus the square root of 5 plus 1 minus the square root of 5, well, if I add the nice thing is the square root of 5's cancel, I just get 2. And since that is the opposite of b, well, I know that means that b is negative 2 in my polynomial. Okay? If I look at the next part, it says that if I were to multiply, I'm just getting this from the front side of the paper, so go back to the front side of the paper and look at the rules if you need to. I would memorize those, hint, hint. So it says if I multiply these, I will get the constant term or the c term. So if I look right here, if I take 1 plus the square root of 5, 1 minus the square root of 5. If I multiply those together, well, I end up getting 1 as my first terms. The nice thing, if you remember multiplying conjugates, the insides, the outers and the inners cancel. So if I multiply the last, I'm just going to get square root of 25 or 5. Well, I end up getting negative 4 as my constant value, and that's just c. So all I can do is I can write this and just say, well, f of x is equal to, now it's got to be a 1 in front of the x squared, and you write this. So if we have 2 roots, we added them together, and we got 2. That's the opposite of b, so that means that b is negative 2. See how I just kind of put that in there? And then if I multiply my 2 roots, that comes out to be your c. which is -4. So to me, if you memorize it, that problem is a lot easier instead of trying to multiply all that out and combine like terms. I think kind of goes up pretty easy that way and sets it up like that. Okay? All right. So number 7, if you wanted to go back up here, you could double check it, right? If you were to take number 4, here's my hint, my suggestion to you. Take number 4, try it. Try out that pattern that was on the front page, where if you add them together, you get opposite of B. So if you do 1, 1 twice, so 1 plus 1 plus -3, right? That's going to be the opposite of your B, right? So if I do 1 plus 1 plus -3, well, that's going to be -1. Oh, look, we got +1, right? So then if I take 1 times -3, well, that's going to be -3. Well, that was the opposite of D. Okay, see how that's working? And then if I do my combination, that will help me get -5. Okay, so go ahead and try that. See how you're doing see how you do that. Double check that it works. Should work out pretty nicely. All right, last problem that we got here. Find the quadratic function with the zeros at -4 and 9 that passes through 3, 5. Now here's a little bit trickier. This passing through is what's going to make it a little bit more challenging. So we still have a quadratic function, so we still say a function equals, well, the 0 comes from x plus 4. I left a little bit of space on purpose. And then that 9 comes from the quantity x minus 9. Now here's the tricky thing. Because we're going through 3, 5, and it's not going through just, it didn't tell us specifically before, so we didn't have to worry about it. What I'm going to do is I'm going to put an A to represent some type of coefficient, a lead coefficient that we have there. All right, so I'm just going to put A there to represent the lead coefficient. And I'm just going to plug in, right? If you remember, this is really just telling us, we talked earlier, that f of 3 equals 5. That when x is 3, y is 5. So I'm just going to put that in. I'm going to let 5 be equal to, I don't know what A is yet, and instead I'm going to have here 3 plus 4, 3 minus 9. So I'm plugging this in to find the lead coefficient. Because if it goes through 3, 5, that means there's a good chance the lead coefficient is not 1. But I got to find that out. So I'm going to say, okay, 5 equals A. I'm going to have 3 plus 4 gives me 7. 3 minus 9 gives me -6. So this is just -42A. So my goal is to solve for A. So if I divide by -42, divide by -42, I end up getting that A is -5/42. I know it's an ugly looking fraction, but that's your lead coefficient. So it says find the quadratic function. So if I put that in here, so if I have f of x equals -5/42, x plus 4, x minus 9, this is a fantastic quadratic function. Okay, that's a fantastic quadratic function that if it doesn't specify, you can leave your answer like that because that is a quadratic function just written in factored form. Okay, if it does specify like we've been doing already, so you would need to FOIL, you would need to distribute, right, all of that. If you do it correctly, and this is a chance for you to try this, do this correctly. I had that f of x is equal to -5/42 x squared plus 25/42 x plus 30/7. So this would be as the polynomial form, right? Again, multiply these two groups out, then distribute, and you should get that particular answer. Okay, so there you go. There is day 3 for chapter 13. If you got questions, please ask your teacher.